With your partner, model the expression x squared plus 6x plus 9 with the blocks. Okay, then when we get the pieces out, okay, once you have the pieces out, go ahead and draw it on your paper. How many of the big orange squares did you pull out? 1, and then inside, put x squared, because that's what it represents. How many carrot sticks did you get? 6. And how many little green squares, unit squares? 9. I'm going to cheat and just use an area model for that. All with area 1. Yep. Brandy, you'll want to watch the video on my website to finish it, but there won't be any additional homework because we're not, Monday's short. We're not quite ready. But tomorrow, Wednesday, there will be. Okay, I hope you still have those pieces separated out. Using the ones you just got into a group, we're going to do number 2. So on number 2, you have to use all of those pieces. So you have an x squared plus 6 carrot sticks will put you up to 7, plus 9 of these. So, what, 16 pieces. You have to use all 16 pieces for number 2. And no more, no less. This trinomial is exactly the same. So using all 16 pieces, you put them together so that they make one big perfect square. Not a triangle. One big perfect square. Arrange them so you get one perfect square. It's like a puzzle. They have to actually link up. The sides have to match in order to put them together. No. Two-dimensional square. Two-dimensional square. Okay, you ladies are on the right track. You need to be careful though. That's not quite a square. It's more of a rectangle. Okay, you're on the right track though. Not three-dimensional.
Oh,
two-dimensional square. Three-dimensional, I would have said cube. Two-dimensional means flat. Flat square. Okay, you guys are on the right track. Keep going. Keep going. You got it. Make a perfect square. It's kind of one of those tangram things. I used to like to play with those. Good. Good job. There's a couple of different ways to do it. No, you can still do that. Keep going. It still works. This is a different way, but it'll work. Okay, that's a very creative way to do it. I don't think it visually pleasing, but I don't think sides are actually lining up correctly. Because it's like a puzzle. You can only put matching sides together.
Okay.
Okay? Okay, that only has 4 sticks. You need 6. Good, girls. Okay, yours is really close. The only adjustment you need is here.
Oh.
Do you know why I had to adjust it like that?
So they could.
Yeah, because they have to match sides by sides.
Okay.
Okay, so that is one way. There's actually 2 different ways you can draw this out. That's one of them. That works. Yes, that works. Good.
don't use all of them, you only use 16.
Just 6. Yeah, you're done. That's it.
Ooh, yay.
Yeah, those are extras. You only need to use 1, 2, 3, 4, 5, 6 of the sticks. Okay, so you guys have 4. Squares have to be equal length and width, right? So however many sticks you put down, you have to put the same amount sideways. Good. You're on your way. Just fill that in. Okay, cool. We had some really interesting artistic work, which looks really pretty, but doesn't quite work like a puzzle works. Okay, how many sticks are we supposed to be using? 6. So I kind of like this one because it looked pretty, but it wasn't. I don't remember how you all did it. Something like this, and then there's like something like this, and then there's like something like this. It looks all pretty, and then we had how many of these? 9, 3, 4, 5. Whatever yours is, don't touch it. Just leave it like that. 6, 7, 8, 9. Now this looks pretty. Nice and artistic. But it doesn't fit together quite like a puzzle. When you're doing a puzzle, you have to put matching lengths together, right? So, we don't actually, if this is my X, I don't actually know. Some people are doing this too. I don't actually know that this X is 3 units. It could even be 3.5. I don't actually know. Okay, I have to put an X by an X. So if I wanted to line something up on the square, I'd have to put an X by an X. You guys see how this length is the same as this length? X and X. So they're like flush. I guess you would use that in like building, flush together. Now there are 2, oh, that's really pretty. So if you're going to, a mosaic for the bathroom tiled floor. That's what you should do, right? Okay. Here is one option for your square that works. And I saw a few groups came up with it. And some groups got this far and then they got stuck because they had to use 2 more. Where did I put the other 2? One on the side, one on the sides, either side, and one on the top or the bottom. And then I fill in with 9. 3, 4, 5, 6, 7, 8, 9. Let's actually make sure this is in fact a square. Let's look at the dimensions. What is the length from there to there? X plus how many units? 3. What is the length from here to here? X plus how much? 3 if we do the full length. Okay, so it is a square. This is another way you can do the same thing. I don't want to mess that one up because I think that one's pretty. Okay, here's another way to get the exact same thing. Oops, I can't do this, right? That's not legal. I have to put this one over here. 1, 2, 3. 1, 2, 3. And where do I put the green pieces? Yeah, in the bottom corner. 1, 2, 3, 4, 5. Man, this is a workout. 6. I feel like I'm like working out my arm right now. Okay. This is also a square. Let's make sure. What's the length? How long are each of those individual sticks? 3. Or they're 1, so together they're 3. X plus 3. And how wide is it? X plus 3. Okay, so you need one of them. On your paper, will you draw out whichever one you came up with? On number 2, draw it out, and then answer the question. Why do we call this trinomial a perfect square trinomial? Were we able to make a perfect square with all the pieces? Yeah, so why is it called a perfect square trinomial? Don't just say, it makes a perfect square. Well, be a little more specific. Why do we call it a perfect square trinomial? Talk about it with your partner. How could you explain why we call this specific trinomial a perfect square trinomial? Okay, let's hear some of your answers for why do we call this perfect square trinomial. Who wants to share? Yeah?
You can square all the terms in the trinomial.
What do you mean by squaring all the terms? Oh, interesting, interesting. Interesting take. So, square root of x was, and we ended up having, let's see, let me draw that in really quick. Let's see, so we had our big X, and we had, how many of these? 3. And then we had 9, right? So we had X plus 3 and X plus 3. So she's saying if we take the square root of X, we get X. If we take the square root of 9, we get 3. If we take the square root of 6, okay, that's how we get the factors, yeah. Okay, other ideas of why we call this a perfect square trinomial? Done? Okay. So we can take all of the individual pieces and literally form a perfect square such that the length and the width are exactly the same. So our binomial is, and this one, x plus 3 squared for the area. Area of the binomial is x plus 3 squared. So we can make an area model using all the pieces, each individual term from the trinomial, and make a perfect square visually by arranging them, because the length and the width are exactly the same, or the two factors we get from the dimensions are exactly the same, right? So you can take the dimension and square it, and you have the area. You need to form that in one sentence and write your answer down. We call this a perfect square trinomial because we can take all of the terms and arrange them visually into a perfect square, because the length and width are the same binomial, right? The length and the width are the exact same binomial. If you're looking for the dimensions, the length and the width of the square are the exact same. They're the same binomial. Okay. All right. Now we're going to change the problem. Number 3, we have a new trinomial, but one of the terms is missing. Says we will now use algebra tiles to create a perfect square trinomial. So when we're building this, should we be building a star? Should we be building a circle? No, what shape should we be building? A square. Now, all squares are rectangles, but not all rectangles are squares. So make sure you're not just building a rectangle. That's not a square. You're going to create a partial square to represent x squared plus 2x. We don't know the last term. Create a partial square so that we have x squared plus 2x. With your tiles and your partner. Tyler, are you working with Ashley? Dylan, Darter, are you working with Kayla? Okay, work together with the tiles. Build a partial square. X squared plus 2x. Good. Now this is looking like a rectangle to me, not a square. Yep, that's exactly what you need to do. Okay, now remember how we talked about flush like a puzzle? You don't know that that's actually a unit, so yeah, you have to move it down. Okay, part B, how many tiles do you need to complete the square? How many green tiles are needed to complete the square? Yep, that's right. Now, determine with you and your partner how many green tiles are needed to complete the square. Yep. Right, just in that corner. Yep.
So do we draw that?
Yep, and draw it. I think we all have it. You all got something like this, right? And you have to put one on the side and one on the width because your length and the width have to be increasing by the same amount in order to keep a square. So your green tiles, how many do you have to add in that little corner? 1. So 1 unit tile. What are the dimensions or factors now of the completed square? X plus 1 times x plus 1, which equals, and wants us to write it in factor form and as a square. So x plus 1 times x plus 1 is also x plus 1 squared. Okay, without just restating the builded, this lesson is called Completing the Square. D says, why do you think the process we just did is called completing the square? And you can't just say because we completed a square. Okay, that's like the dictionary using the same word to define the word. Okay. So, with you and your partner, I want you to come up with a sentence that's not just saying because we completed the square, to explain why we call this process completing the square. What the steps we just did is I gave you only x squared plus 2x, and you had to fill in the blank. Filling in that blank is called completing the square. You had to figure out how many tiles had to be inserted in. Okay? With your partner, determine why is this process we just did in number, what number is it? 3. Why is it called completing the square?
You finished this. Shh.
Don't say that. What? It's a little more than that.
Okay, so we like.
Starting with x squared plus 2x. Remember, we started with x squared plus 2x. It was not a full square yet. We started with x squared plus 2x. We made it into what type of a square? A whole square? No, we made it into a partial square first. And then, did it ever tell us plus 1 in the problem? No, we had to determine how many green tiles we put in. And how did we decide it was 1 and not 9? Because 1 made it a perfect square. Okay, so who can tell me their sentence? Or why do you think we just call this process completing the square? Yes? Ooh, I want to say last dimension. Last term. Okay, finding the missing C term. Or you could say, given a partial square, because x squared plus 2x was a partial square. Given a partial square, we found the missing term, or the amount of green tiles we needed to insert in to make it a perfect square. All right, when you're done there, flip it over. All right, please stay with us. Don't go ahead. And we're going to reorganize the order that we do these columns in. We're going to do this first empty column first, and then we're going to do the last empty column second. The one that says perfect square binomial, we're going to jump over to that. And then where it says trinomial, we're going to do that last. So, please stay with us. Don't jump ahead. The process of going through this chart, we're trying to discover a formula for how we come up with the number of green tiles to insert in. Because for every trinomial given, or partial trinomial, partial square, we can come up with how many green tiles to enter in. And there will be a formula. You're trying to discover that today. So, with your partner, build, please, x squared plus 4x, that's our partial, and decide how many you have to enter in to make C. C is the green tiles to make it a perfect square. Okay? Okay, fingers in the air. How many did you get for C, the number of green tiles to enter in? Good. We all came up with 4. Does anyone not know how we got 4? All right, now we're going to jump over to the very last column. We're going to write this as a perfect square trinomial. Look at what you formed on your desk. What are the dimensions? X plus 2 by x plus 2, so we would write that as x plus 2 squared. X plus 2 all squared, because length and width are the same. And lastly, the trinomial is just x squared plus 4x plus, what was C? 4. Good. Okay, any questions on that line? Okay, will you go do the second one, please, and then stop. Don't do the third one until it's time. X squared plus 6x plus C. We don't know what C is. Build it so you can visualize, so you can figure out the dimensions. You're helping her build? Ah, good. And then how many green tiles do you have to insert in to make it work? Alright, fingers in the air. How many green tiles did you get? Fingers in the air. How many green tiles? Good. We should all have 9? 8? Oh, 9. Sign language 9. Okay, 9. So, skipping to the last column. Look at your dimensions. Okay, Alicia, what are the dimensions? Ah, there you go, squared. X plus 3 all squared. Okay. Tyler, what would the trinomial be, filling in a value for C? Good. Alrighty. Can you and your partner go do the last 2 rows? Now when you get to the very bottom one with 10, you don't have enough sticks for that. By that point, you should start processing what we're doing, and you should be able to still figure it out. After you're done, start trying to come up with a formula, a mathematical formula of how we can find C each time without building it, or without drawing it. Algebraically, how could we find C? Uh-oh, you're missing one? Did you drop one? These. Good, Caitlin. Okay, now you two start discussing a mathematical algebraic formula to how we can get this from this. You can draw it, or can you figure it out without drawing it? Are you able to visualize those now? Okay, finish. What's the perfect square binomial now? What are the dimensions of this? X plus 4 squared.
36.
Okay. The next one you don't have enough of the sticks to do, but just imagine putting one more on.
That makes sense.
Okay. Yeah, you don't have enough sticks this time for the
They're
10.
using it well. Well, we were talking this one, but we're done.
Yeah, they're using ours, so it's not like 25.
Okay. Well, can you do it without the sticks? Do you know what's going on enough now? Wow, Jenga going on over here. Did you come up with the formula?
Yep.
When you have all that filled out, you should be looking at how could I algebraically, without using blocks or without drawing it, how can I take my trinomial and get C? Every other class has come up with the formula. I believe in you. You can do it too. How do we take the trinomial and come up with the C value without drawing it, without visualizing it, without building it, but just using algebra? I think it's 6. Yeah. Oh, you just wait. You just wait. That's the easy part today. Okay, I want to hear what you have on the next 2 lines. X squared plus 8x plus C. Rekha, what did you and Sadie get for a number of tiles needed? 16, that sounds right to me. Sadie, what was your guys' binomial? X plus 4 all squared. And so this was x squared plus 8x plus that 16, right? Okay, the next one you didn't have enough tiles for, but how many green tiles ended up being inserted in? 25. So what would the binomial be? Okay, so we have x squared plus 10x plus 25. Okay, for part number 6, we're kind of skipping number 5. Number 6, we're trying to look at find a formula from how we can go from this column and get these algebraically. How can we take the trinomial and instantly know C? Okay, look at it, work with your neighbor, try to come up with it together. Toss off your ideas, what you're thinking. Fatima and Kevin seem happy over there. Make sure it works for all 4 of them, whatever you're hypothesizing. Okay, about 5 more seconds. 3, 2, 1. Okay, who thinks they found the formula? Well, this row, apparently. Anyone else? Oh, I have some fingers pointing to the Pika. Okay. I saw them go through, and it looks like it works for everything, so I'm going to hold your answer for a minute. Because they're like, oh, yeah, they went through each line. They're like, oh, it works. Okay. Let's go to Depika. What do you have, Depika? He's just pointing at you for fun. Okay. Maybe we'll give her a break. Okay, ladies, you had one too, right? What were you thinking?
Oh, we would number divided by 2 and squared.
What?
Middle number divided by 2 and squared.
Okay, middle number divided by 2 and squared. And what were you guys thinking? Do you have a name for middle number? B. B divided by 2 squared. A, B, C. Let's make sure it works. What's 4 divided by 2? 2 squared is 4. What's 6 divided by 2? 3 squared is 9. What's 8 divided by 2? 4 squared is 10 divided by 2? 5 squared? Ah. Cool. So we're skipping 5. We're just going to go to 6. C equals B over 2 all squared. Great job for figuring that formula out. B squared, B parentheses squared. It can't be X. It has to be B squared. Okay, we're going to now use this to complete the square without using our blocks. So from now on, hands off the blocks. Step away from the blocks. You can just leave them as is on your desk. We'll clean them up in a minute. Put that in your bag, please. Oh, it's a pencil. Sorry. Usually when people have something under their desk, it's a phone. Oh, this is a very good point. Okay, number 7. The more you write the formula, the better it will be memorized. So please, each problem, write the formula. C equals B over 2 squared. We're trying to find the C value that completes the square, and then we're going to write our answer in factored form. Adam, step away from the blocks, please. Okay, Adam, what is our B value? Coefficient. 12, great. So we have 12 over 2 squared. Please be writing all this work on your notes. We use, please excuse my dear Aunt Sally, PEMDAS to simplify. Happy face. Okay, that was weird. What do we do first to simplify? Divide. 12 divided by 2 is 6 parentheses. Put parentheses there, important, squared. I'm going to star this simplified 6 for a reason. 6 squared is 36, right? So if we take the original, I'll write it out here because I ran out of room. Bracket form, or the polynomial x squared plus 12x plus, what is C? 36. We just had a test on factoring. We want to write the expressions using factored form. What are two numbers that multiply to 36 and add to 12? And negative 6 and negative 6, right? Which one adds to 12? Pauses. It has to be the pauses. So our factored form, we have x plus 6 all squared. Any relationship to what I starred? Yes, the simplified form is what goes in there, right? Let's do another one. Write down that formula again. C equals, what's the formula? B over 2 all squared. Write it down. The more you write it down, the more memorized it will become. Okay, Cindy, what is our B on part B? That's kind of confusing. Good. She grabbed the negative. That's exactly what you're supposed to do. It's not just 6. It is negative 6. But it's okay. Can we add negative tiles? No, but we're squaring it. So wouldn't it be positive anyway? But we do need the negative 6 for a reason. What is negative 6 divided by 2? Negative 3 squared. When I get to that simplified form, I'm going to star it. What is negative 3 squared? Positive 9. See, we can add positive 9 tiles, so that's okay. So on my polynomial, I have x squared plus, not plus, minus 6x, what was C? Plus 9. So finding C means you're finding how many green tiles are sticking in the corner. What two numbers multiply to 9 and add to negative 6? Oh, we have to use negatives, huh? Negative 3 and negative 3. Exactly. Say that louder. Good. X minus 3 squared. Does that have anything to do with what I starred? Yes, that's why you need to have that negative sign. It is the same number. Okay, this next one is not an even number. Okay, C equals B over 2 all squared. What is B this time? 3. Ooh. 3 over 2 squared. We need to simplify. What is 3 over 2? But does the fraction simplify any further? No. I'm going to start because it is simplified. 3 over 2 squared. 3 squared is 9. And what's 2 squared? 4. So you can just square the top and bottom, which is 9/4. Okay, so our trinomial is x squared plus 3x plus 9/4. Which you guys have already said, 3/2 is 1.5. What is 9/4? 4.5, 2.25, is that right? Someone calculate that for me. 2.25, okay. What multiplies to 9/4 and adds to 3? 1.5. Isn't it the starred part? 3/2 times 3/2 is 9/4. And 3/2, 1.5 plus 1.5, isn't that 3? So whenever we've simplified the parentheses, that becomes your perfect square, the dimensions. Right? So we have x, it was a positive 3/2. If you want to write 1.5, you can write 1.5 and put 3/2. Okay, flip it over. Okay. We're skipping most of these. I think we're just doing number 10 and 11. Okay, number 10. Using this process, write each in factored form. Factored form. So when we're finding the C, we are finding that part of the factor. What was the formula for C? B over 2 squared. Because we're finding the factored form. And remember there is a connection with those stars. As you're finding C, you get that number that belongs in the factored form. Not tonight. We have a day 2 of it. You can there is a math Excel assignment assigned to you. You can start, but any of the problems that say solve, you don't know how to do yet.
Can't we just like square the C?
What?
Can't we just square the C to get the number?
We're not trying to get B, we're trying to find C. You can square root 49, sure, but then sometimes you have fractions, sometimes you don't have pretty ones. So yeah, you can think, this one's easy, to think of two numbers that multiply to 49 and add to 14, but sometimes it's not an easy one. So if it's not an easy one, you go through this, 14 over 2 squared, which is 7 squared, which she's right. Isn't 7 just the square root of 49? Yep, so we have x plus 7 squared. Can we take the square root of 25/4? What's the square root of 25? 5 and square root of 4, 2. So even though that looks scary, it actually becomes 5/2 squared. Can we take the square root of 16? What are our dimensions going to be? X plus 4 squared. Okay, for the remainder of class, I want you to fill in this table. Do it in this order, though. Find C, and secondly, write your binomial, which is that last column. After you've written your binomial, you can do the middle column. Okay, if you can pick, and now maybe finish those parts for homework, because the bell's going to ring in a sec. I do need all your, please clean this up correctly. Last class didn't listen. Okay, so quiet and look at me, please. In the baggie with the orange squares should go the green squares. Squares all go in the same baggie. Orange and green squares together. The carrot sticks in their own baggie. Please look on the floor to make sure you have everything picked up. You didn't lose any pieces. And bring them up to the front here. And I need your calculators as well. Next time we're going to learn how to solve these. Oh. Next time we're going to learn how to solve these. Today all we're learning is how to find C and write the binomial. Yeah, just do 12 through 18 is homework. They're quick, right? It's not too bad. That way we can just continue on next time. Thank you. Bring the calculators back in order, please.